Okay, so in this video we're going to be talking about diagnosing big IP DNS issues. So as we can continue on into section 3, we're on objective 302, and we're going to talk about virtual server flapping, health monitor iQuery operation, and confirming DNS patterns. Okay, so let's take a look at that DNS exam blueprint. So objective 302, diagnose big IP DNS issues. Some examples are investigate root cause for virtual server flapping issue and analyze DNS request/response pattern to confirm big IP DNS configuration, health monitor, and iQuery operation. Okay, so let's take a look at our first big IP DNS issue called virtual server flapping. So virtual server flapping can happen via a lack of a unified view of the iQuery mesh, which causes unpredictable behavior. So for example, if you have a big IP DNS device that is not currently connected to the same set of other big IP DNS devices, this can cause a disagreement of who's monitoring a specific object virtual server. So let's say you have a DNS device over here, and another one over here, and a third over here. Okay, now these were all part of a sync group at one point, but let's say this third DNS box, the device certificate failed, which caused that not to participate in that sync group anymore, but it still is trying to probe, let's say, this LTM device behind it, which validates our VIPs on that LTM, and then our generic hosts as well. Okay, so these devices are all monitoring these specific servers, but if this DNS device essentially loses its capability for iQuery via the part of its same sync group, and it tries to query on its own, well, it can still send incompatible results based on the status of these. If maybe this DNS device has a separate path, like a private link to these generic hosts. So and an inconsistency in which DNS device is actively monitoring a specific host could cause the virtual server flapping to happen. And this is also an issue too, because all big IP DNS devices in a particular sync group agree on which DNS device will monitor or initiate the monitoring request. So if this DNS is pulled from the sync group and unable to communicate with other DNS devices, that can lead to the virtual server flapping. Okay, and another use case is maybe an imbalanced LB method such as ratio. When you're overloading one server more than another, it could result in virtual server flapping. A special use case would be if all the following conditions are met. So first you have a generic host at DC1, another at DC2, and then these generic hosts communicate on an internal network. Say they have a private link. Then these two monitors associated with the generic host have the same name, but each uses a different alias, IP, and port. So the solution is to make sure that this monitor is a transparent monitor. You can see a screenshot right here, but this allows you to make the configuration unique per the generic host monitoring, so it combats issues with virtual server flapping using the same monitor on both DC1 and DC2. Okay, so let's look at our next example, monitoring iQuery mesh. So the iQuery mesh is basically a set of devices that have long-lived connections, and they're made up using TCP port 4353, the proprietary port for iQuery. And these set of connections are among DNS devices and between DNS devices and LTN devices. So they're a pairing, right, of proprietary F5 products. Okay, so you can get the status in the GUI page in the GSLB server object list. You can also get it from the command line. So if you see that green in the server list, that indicates that the iQuery connection is successful. You can also do the TMSH show GTM iQuery to get a status of all the iQuery connections. Okay, to get an idea of what that looks like via the command line, you can go into TMSH, do a show GTM iQuery, and let's see if there's all. This might show additional information. Okay, so you can see that my current local GTM, it shows the server type, the data center, and the state connected. Okay, so if you go down to our next iQuery device, this shows it's in a state of connecting. So obviously we want to verify all the troubleshooting aspects from our previous videos in resolving issues with iQuery and the connectivity. But this just allows you to have a quick idea of all the servers that are connected, and ideally you want every device, even LTM, GTM, in each DNS device to be in a connected state. So if you wanted to grep for connecting, and you basically want all these to go away. Okay, and obviously we looked at a lot of examples in previous videos for troubleshooting iQuery, so we won't go over that in detail, but just wanted to show you the command that's available. To start, I mean, you just start with basic connectivity to the respective device, and I would start with a ping test. So ping fails. This LTM HA pair is the VE that I have is not up right now, so that's the first step. Second would be verifying port 4353 via the netcat utility we talked about, and then of course validating the certificates. The device certificates are exchanged on both devices via using either the big 3D install or the big IP add command. Alright, so as we continue to look at monitoring iQuery mesh, an important place to look is the varlog GTM log file, as it shows us the connection status messages regarding changes to the big 3D agent. And remember, this was an important agent used to discover and listen to that sync group when we're actually getting statistics for iQuery. So it reports on connection loss status, connection generated, if it's established. So we'll look at a couple examples of a lost message. So in this case we look at the varlog GTM, we can see the SNMP trap as it sends out the status message, and in this case we're looking at this specific device 209 goes from a status of green to red and is marked unavailable. And if we look down one log, we see that same IP address, which is associated to GTM3 going from green to red, no communication. So this indicates our third GTM has lost its communication, maybe a missed firewall rule or a disabled port on the network is occurring that is not allowing us, in this case maybe GTM1, to communicate to GTM3, or even a GTM3 log message would indicate this as well. Okay, and here's a look at a example connection established message. So here we see that same GTM going from red to green, and then it lists the name of the object going from red to green. So if this is happening quite frequently between intervals, then it's obviously indicative of what we saw previously with a virtual server flapping on that GTM. So what logs does it show if iQuery is blocked? Okay, so it can be blocked by a router ACL, a packet filter. It marks it as unavailable if it tries to reestablish the connection every 10 seconds. And this you can actually change in the GSLB settings, but by default it is 10 seconds. And you can see the log sequence when it's trying to connect to that box. So we'll go from red, green to red, and green to red. We saw those two in the previous slide, and then it will just continue connection in progress to iQuery peer every 10 seconds. Okay, so here's what you want to see in the varlog GTM is a successful iQuery connection. So we make a connection in progress message to the iQuery peer. We're starting the SSL handshake, and we're going, once it's connected, we'll go from a red to a green status, and then we should also see that it joined a specific sync group. In this case, the default sync group was joined by that GTM device. Okay, so last we're going to look at confirming GSLB patterns. This is based on version 14. So here are a few commands used to identify the GSLB patterns. And if you remember, there's really two components to the F5 DNS. There's either GSLB functions or non-GSLB functions. When we're looking at GSLB functions, this is things like the wide IP and pools. If we're looking at non-GSLB, that's more of the listener and DNS profile. So first we're going to take a look at GSLB, wide IPs, and GTM pools. So if you're curious about what's happening with the load balancing coming into the wide IP, and I want to confirm that it's making the right decisions based on what I set it up for, well, you can use the GUI. You can also use the command line. So in this case, we're doing a show GTM wide IP, and site request is listed here, and you can either specify the type of wide IP it is. I'm just doing a show GTM wide IP, so it's dumping out all the wide IP information. But if you wanted the specific, you'd see this is the A record, so show GTM wide IP A, and then the wide IP name if you have a specific one you want to look over. And this includes the requests and the load balancing methods used. That would be the first thing to check to verify the pattern for your GSLB. And the same, it actually lists the same output for the pool information as well. Okay, so now let's look at confirming non-GSLB patterns, and this is also based off version 14. So this is quite an extensive list because DNS in general would have a lot of options to filter on and verify the functionality. So as it's a broader scope, right? So if we create a DNS profile and we call it DNS, and then we apply this to our listener, then we can see all the information about that traffic coming into that profile / listener. We've got a summary, the component statistics, including GTM, DNS Express, cache resolver queries, backend DNS queries, DNS 6.4, unhandled query actions, query message, the question type, and this actually extends into response message, other packets, the license service rates based on that platform, and the rapid response mode if you choose to enable that, and the hardware acceleration. Obviously you can see the non-GSLB functions for the DNS profile is much more extensive because we're looking at a broad range of traffic coming in, not specific to you're coming into a specific wide IP with an A record or a CNAME, etc. So this is very useful to identify the patterns related to non-GSLB functions. And also, if you haven't had a chance, I'd highly recommend reviewing section 1 as it goes over the LB methods and reviews how to verify successful operations when we jump into the command line and everything like that. So this is, again, should be kind of an overview as we dived into it in section 1. Alright, nice work. So in this video we talked about diagnosing big IP DNS issues on Objective 302. In particular, we talked about virtual server flapping, health monitoring, iQuery operation, and confirming DNS patterns via non-GSLB and GSLB patterns. So up next, we're going to talk about analyzing system log data and statistics for problem analysis in Objective 303. I'll see you in the next one.